Hello again, everyone. This is Nick Stramick and Howard Chao with What's Next In, our startup-based podcast. And today we're speaking with the founder of Ascendance Flight Technologies. So Ascendance is a VTOL, or vertical takeoff and landing startup based in Toulouse, France, that designs aircraft for urban and regional use. Howard, you actually recently visited Ascendance in France. Tell us a little bit about what you thought about this company.
I think it's a very unusual situation and very exciting. I happened to be in southern France this past June on a little biking trip, and I visited a few companies and investors in Toulouse as part of the trip. And it turned out that this team is a long time group working in Airbus, which obviously is a leading aviation manufacturer based in Toulouse. And they've been working on electrification of aviation for a long time. It's an impressive team. They've made a lot of progress. It's pretty clearly the French national champion when it comes to the future of VTOL. It looks like they will be showcasing their technology at the Paris Olympics. And so I think it's an exciting opportunity and project. So I'm sure that our audience will be interested to hear this.
Great. All right, let's go ahead and get right into it. This is Howard interviewing the founder of Ascendance Flight Technologies.
And today here with me is Thibault Baldivia, one of the co-founders of Ascendance. And to do the interview with me will be Patrick Hogan of Honeywell. So I'm pleased to have both of them with me today. I'm going to start by asking Patrick Hogan to self-introduce and tell us a little bit about what he and his team does at Honeywell.
Thank you, Howard. Patrick here. I represent Honeywell Ventures. That's the early stage disruptive investment arm of Honeywell, which is a $38 billion global business. And we're very, very focused in helping to work with new startup companies, Howard, particularly that are invested in the areas of technology that are really going to change how the world is traveling, how we work, how we live, how we're going to impart knowledge in the not so distant future. And a big part of that is all of that is a big decarbonization theme as well. So very excited about the conference coming up in October, meeting with great investors and great startup companies there as well.
Great. Well, thank you for joining us. So Thibault, it's late at night for you in Toulouse, France, so we appreciate you joining us for this. I was very pleased to meet you and your colleagues in Toulouse on a recent trip there, and very impressed with what you're up to. But why don't you share with the group your background, your team background, and also what your company's about?
Yes, thank you very much about that, Howard. So my name is Thibault. I'm one of the co-founders of the company Ascendance. I'm Chief Customer Officer there, but I've started my career in research programs at Airbus. I'm trying to hybridize aircraft, rotorcrafts, UAVs. In 2014, I got the chance to join the EFAN program, which was one of the very first all-electrical aircraft in the world. And this is actually where I met the three other co-founders, so we have four. We used to work together at Airbus on this first electrical aircraft. We saw the potential for electrification in aviation, and that is actually the trigger where we decided after that to leave the group and start our own company to promote those more electrical technologies.
Would it be fair to say that you were essentially the core of the group at Airbus that was working on this set of issues?
Yeah, absolutely. I mean, for example, Jean-Christophe, my colleague and my business partner, was the project leader of the EFAN 1.1, who is famous for having crossed the channel, the English Channel, which is still the first and the only electric aircraft to have done so. So yes, definitely there was the core team. We saw the technology, but also the drawbacks from only batteries, especially from an operational point of view, the constraints that we had. So this is actually one of the very first foundation of Ascendance, which led us to choose hybrid electric technologies.
Very good. So tell us now about the aircraft that you're developing. Maybe you can describe it.
Yes, definitely. So what we're doing once again is revolving around hybrid electric technologies. So we are developing ATEA. You can actually see the tail of the aircraft behind me. So ATEA is a vertical takeoff and landing aircraft who is designed for regional air mobility. So it's rather a long range aircraft. So as you can see here, we have a range of 300 miles, 400 kilometers. We are carrying 1 pilot and 4 passengers. And one thing here, which is really important, is we have actually a hybrid electric propulsion. So we are taking off full electric to limit the noise and the pollution at low altitude. And then we are using the hybrid electric part to propel our aircraft in cruise mode, which leads us to the capability also to recharge in flight. So the aircraft itself is kind of a plug-in hybrid, if you like. So you can recharge on the ground with an electrical charging station if you want to reduce CO2 emissions to the maximum possible. But you also have the capability to recharge in flight if you ever land on somewhere which is not equipped with electrical charging station. So this is really what we're trying to do here, be able to link remote places with these aircrafts, while keeping in mind the fact that at the end of the day, we want to be net zero emissions with hydrogen or with sustainable aviation fuel. But while we still have some challenges with those technologies, especially on the infrastructure side, these are very aircraft here using kerosene, conventional kerosene, Jet A1, is already able to reduce by up to 80% the CO2 emissions and by 4 the noise compared to a helicopter.
Thibault, it's Patrick. Is that a smart risk when you think about how many things that you're trying to innovate here? You know, not only a new flying platform, but also multiple different fuel sources, propulsion sources as well. What made you and the team believe this was a necessary challenge to go take on when you're dealing with so many different things at the same time?
Actually, I fully agree with you. This is a challenge to deal with all those technologies at the same time. So this is what the hybrid electric technology allows us to do. We can actually tackle them sequentially. At first, we are doing a hybrid electric propulsion system with conventional fuel. So we are kind of limiting the number of new technologies we're introducing in the aircraft. Then once we will have that fully integrated, fully operational, commercially available, and that hydrogen or sustainable aviation fuel will have more mature technologies, then at this point, we will integrate them into our aircraft. This is the beauty of hybrid electric technologies, that our technology is actually modular to those new fuels, and it can accept either one with minor or less minor modifications in the propulsion system, which allows us to really tackle one thing at a time.
So can I ask two sort of semi-technical questions as a matter of curiosity? So I've noticed in many of these VTOL aircraft designs that some have propellers on the outside and then some are in the wing. Maybe you can just say a little bit about the pros and cons of those two choices. And second of all, can you describe what would be the typical pattern of energy usage or propulsion usage for a flight? In other words, is it a short distance electric and then the rest of it is fuel, or how much of the flights typically would be electric and how much would be fuel?
Yes, definitely. So the first thing when it comes to the rotors, so the aircraft itself, you are taking off vertically and landing vertically, of course, using the 8 rotors that you have embedded in the wings. And when you are in cruise flight, you are actually using both propellers that are not really shown well in the image, which are in the nose and the tail of the aircraft. So we are in a configuration that is called lift and cruise configuration. So we have separated propulsion system with no tilting mechanisms or movable parts that could provide a challenge to maintain. So that's the first thing. To answer your question, Howard, those 8 rotors are in the wings for three main reasons. The first one are for a pure performance, from a pure performance perspective. Actually having the shroud around the rotors act as a duct, which is kind of guiding the airflow, improving the performance of the lift rotors. So this is a purely engineering point of view. But there are also two other things. The shroud itself provides kind of what we call the masking acoustic effect. So it's kind of a mask that reduces the propagation of the noise, thus in reducing the overall noise of the aircraft. So this aircraft is also less noisy thanks to this very specific technology. And the final one, which is maybe the most important, it's safety. If you ever have a problem on the rotor and you have a fan blade that is going out of the rotor, the shroud around it will also slow down the blade or even stop the blade, which is an additional layer of safety for the occupants of the aircraft. Okay. And to answer the second part of your question about the pattern usage of energy, so roughly what we're doing is we are taking off vertically using the electrical power that we draw from batteries. So once again, this is really performance. Batteries are really performant. When you're taking off, you have a huge power demand. So we are using batteries where those components are really nice. And then we switch to we have a transition phase, we call that, and then we are in a horizontal flight. And once we are in horizontal flight, in cruise flight, we are using the hybrid electric part, which is the turbine, to actually benefit from the range, from the energy that is contained inside fuel, be it, once again, kerosene or sustainable aviation fuel. And then at the end, we are once again landing in full electrical mode, which allows us to reduce the noise and the pollution while we are at low altitude where it is maybe the most critical.
So what's the range then?
The total range of the aircraft, full maximum takeoff weight, so full passengers, it's 400 kilometers, which is roughly 250 miles. And of course, as we are a hybrid electric technology, we also have what we call a payload range. So if you decrease the number of passengers and increase the volume of fuel, you can actually fly further.
Very good.
So who would be your typical end customer, and what's the value chain between you and maybe a paying passenger? Just curious if you could kind of depict those moments and where the typical profit pools are between you and the end customer or the final flying passenger.
That's a really good question, especially in our field where there are plenty of business models. What we're doing is we are innovating on the aircraft, but actually we are sticking to a conventional model when it comes to the business model. So we are selling the aircraft to air carriers, be it helicopter operators, and actually the bulk of our customers today are helicopter operators, but also fixed wing operators that are willing to use eVTOLs for regional routes. Mm-hmm. The thing here is we do believe in ecosystems, and I think personally that leveraging the customer base that our clients already have will allow us to also accelerate the entry into service of those aircraft and the deployment of all those aircraft worldwide.
So how far have you gotten with your aircraft? Where are you in terms of the development?
So when it comes to the development, we have actually, we went quite far today. We've built 6 prototypes, but we've chosen to start with ground test prototype rather than going directly to a scale 1 flying prototype. So this is the very first prototype that we've ever built back in 2020. And in less than a year, we went from that to a full scale 1 prototype of our aircraft, the propulsion system on the ground. So this is what we called an Iron Bird, which is mimicking the entire propulsive system of the aircraft that we are testing in our facilities in Toulouse. We've also flown several aircraft, subscale aircraft. We've also tested some part of the key technologies that we have. So here you have the shrouded rotors that we were speaking about a couple of minutes ago. And this is really everything which is tested scale 1. Then next year, it will lead us to the scale 1 flying prototype. So we will fly a scale 1 aircraft next year.
Okay. So what's your path to actual certification and human flight?
So human flight, the first one is with the test pilot, it will be next year in 2023, but I understand your question more from a commercial point of view. So there are two milestones here. The first one sequentially is 2024. You mentioned that at the very beginning of the article, we are in France. So we are actually in a consortium in Paris to make a demonstration flight during the 2024 Paris Olympics in partnership with Group ADP, RATP, and the region Île-de-France, which is the Parisian region. And then we also have our target is to get a certification in 2025. So we are already in contact with the EASA certification team in the EASA agency, sorry, in Europe. And we're expecting to have this certification in 2025.
Thibault, to get that kind of timeline and create the demand, what are the other technologies that you're depending on? What else has to come right? I'm thinking training of pilots, communications, flight control, energy infrastructure. What are all the other things that have to come together to make a whole commercial viable offering?
Yes, you're absolutely right. So there are several propulsive technologies. Maybe the first one we can think about is the battery, but our entire approach is to actually take batteries that are existing today, so state-of-the-art components that we are assembling in specific manner for our aircraft, but the cells, the chemistry that we are using are based on some cells that are commercially available today. But then on top of that, you're completely right. Maybe some of the technologies that are not enough looked at today are the avionics, for example. How does the pilot will actually interact with the aircraft? The flight control systems, we are talking about an aircraft that will have 8 rotors plus 2 propellers. So the flight control systems are actually really critical for this kind of aircraft. And at the end, I told you before, we have an aircraft that has 2 sets of flight control. So you are taking off using the 8 rotors in the wing, and you are flying with the 2 other propellers in the front and the tail of the aircraft. So how does the pilot that? Are they separate controls? Are they the same controls? Of course, we're pushing into the direction to have same controls, but everything which is around the pilot and how this aircraft will be piloted are absolutely key for the development of these new technologies.
Good luck with that. Yeah, thank you.
That's complicated.
It is. But once again, we believe in ecosystem. So yeah, we are working hard with our technical partners on that. We're not expecting to solve every challenges ourselves.
So Thibault, how is your rollout and commercial relationships going to work? Presumably, you're already in discussions with quite a few potential customers and commercial partners. Can you describe the status of that, and what is your game plan or roadmap for that?
Absolutely. We recently announced back in July our first customers. So we announced in July 245 letter of intents for our aircraft, and we are actually now we're at 255, sorry. So those are our partners, our customers that are trusting us and that are also part of what we call our care group, which is a launch customer panel, because for us, it's also very, very, very important to co-design the aircraft with our customers to ensure that at the end, we have an operational fit. And here, let me make just a quick detour, because from a commercial point of view, we also saw the potential of hybrid electric technologies as standalone propulsive technologies. So we've also spinned off, if I can say so, our hybrid electric propulsion system, the technologies that are core to that, and we are offering that to aircraft manufacturer or rotorcraft manufacturer, more conventional ones, to really empower them, if I can say so, propel their new generation aircraft into a new sustainable era. So we are also in discussion, in commercial discussions with those aircraft manufacturers, with those rotorcraft manufacturers, to kind of develop new kind of programs on their end. So be it new version of existing aircraft or completely new aircraft.
And is that partly so that you can accelerate revenues? I mean, presumably those kinds of aircraft might be faster than the VTOL or not?
Absolutely. This is actually, we are doing that both for a short-term and a long-term point. Short-term, you're absolutely right. It's to accelerate revenues. We might be able to get revenues from co-development contract faster than with the aircraft. That's totally true. But it is also because our long-term vision is to make aviation more sustainable. Right. And I think that starting with eVTOLs, which are an alternative to helicopters, to regional mobility, this is a huge, huge first step. But it's not enough to decarbonize the entire aviation commercial flights as we know them. So we need to have a technology that will be able to scale up towards commuters, towards a single aisle, maybe more than that one day. I'm not saying that we will do that next Monday, but at one point, this technology will be able to scale up and tackle the CO2 emissions from conventional aviation, like everyone is knowing. Everyone knows it.
So let me touch on the government relations issues, because I'm assuming that the French government is very supportive of you, and in Europe, the European Union is probably also supportive of you. Can you talk a little bit about what kinds of government supports you are getting, and also how does that affect the geographic rollout of your company?
So when it comes to support from the French government, we are supported by the French government. Actually, President Macron rolled out a plan for what he calls France 2030, which are the 10 strategic axes that he wants to focus on for France in 2030. And actually, decarbonized aviation is the number 5. So we are fully in that, and we are also leveraging this plan to develop our technologies. And but I do think that we are at one point where pretty much all governments and all policymakers are trying to follow the trend, if I can say so. We recently saw that with the recent Inflation Act and the Advanced Air Mobility Act in the US, where you actually have incentives to buy a new mobility means that are less carbonized and more sustainable. So I do think that at the end of the day, we will be able to have a worldwide impact. Of course, it will mean to have some specifics. So for example, in the US, we are actually, we are currently assessing the possibility to assemble and produce some of our aircraft in the US to be able to, provide those fiscal incentive to our future customers in the US.
Well, this is great. Patrick, maybe you have some other questions. We're running short on time.
I do. It's great to talk to an expert like you, Thibault. So you see these beautiful aircraft, and I love all the kind of imagery and the different designs, like Howard said, of different propulsion systems. How does maybe a business person just think about the unit economics? What should I be looking for to compare your product viability with someone else's? Is it energy density per unit weight, kilo, or is it the fee that a commuter will pay for a trip relative to a conventional, maybe hydrocarbon route of doing it? I'm just, what is the level or the data point we've got to see where we see the economics really breaking through and we can compare many different alternates?
I mean, at the end of the day, when everyone will be ready and commercially available, I do think that the metric that everyone will follow will still be revenue per passenger kilometer. So yeah, the number of revenue. Actually, it won't work if we do not have the right economics with this kind of new technologies. For now, what everyone is targeting are a reduction in at least direct operating costs. One point maybe after that, we can also decrease the revenues, the costs from pilots and everything. But this is really what we're trying to do at the moment, reduce those revenues. When it comes to a metric that would maybe allow to, compare different aircraft, I do believe that the revenue per passenger per mile is something important, as well maybe as some other like the range. For me, the performance are really important, because our customers today, they are looking for an aircraft which is capable of achieving a number of different missions, because historically in aviation, we always had aircraft that are modular and flexible. So they are looking for an aircraft which is capable of performing the missions they are doing today, and the new ones they will add thanks to this new capability of this aircraft.
so freight as well as kind of regional transportation, etc.
Absolutely. Yeah.
Thank you. Yeah. Well, good luck with the initiative. It looks awesome. Thank you for sharing.
Thank you very much.
Very exciting.
Well, thank you very much. And once again, thank you for having me here and there, and really looking forward.
Very good. Thank you, Patrick, too.
Thank you, Howard.